It's Tuesday, January 20th, 2015. We're on section 5-5, page 245. It has to do with finding the roots of numbers. It's not like what you knew in Algebra 2 or Algebra 1 where it was square roots. We're going to move past that in what even and odd roots look like third root, fourth root, eighth root. And there is a pattern that we can sort of recognize, sort of like a negative times a negative is what? Always. A positive. If we have an even number of negatives, it's also going to be a positive, isn't it? Because you just pair them up. What happens if you have an odd number of negative numbers? Your answer will be negative. Kind of like negative 3 times negative 2 times negative 1. That will be negative 6. The same applies to roots. Same applies to roots, because something squared is nothing more than, 2 squared is nothing more than 2 times 2. 2 cubed is nothing more than 2 times 2 times 2. But let's think about it. What if we had negative 2 squared? Well, that's an even number and a negative. So negative 2 times negative 2 is 4. So that still applies. The whole paired evens applies. But negative 2 cubed is actually negative 8. Negative 2 times negative 2 is 4. Times negative 2 is negative 8. So that's sort of a very important thing to realize. We're going to be jumping from positive and negatives through this section. I don't expect you to have them all fully memorized, but once you go through what I went through, you pretty much have them memorized. Because you use them all the time. So let's talk about it. So I'm looking at where it says simplify radicals. So the square root sign is also known as a radical sign. In print, it's like that weird V with a tail, and in Braille, it's the ARER stuff. Okay. Simplify radicals. All right. Finding the square root of a number and squaring a number are inverse operations. What does inverse operation mean? Opposite. Good, Ella. They are opposites of one another. So to find the square root, in bold letters, of a number n, you must find a number whose square is n. Okay, that sounds really weird, right? To find the square root of n, you must find whose square is n. Well, let's see what they mean in numbers. For example, 7 is the square root of 49, since 7 to the second power equals 49. Okay, that seems pretty straightforward, right? So 7 times 7 is 49, so the root of 49 is 7. That is what they are saying. But then, see what happens when we talked about this just a second ago? Since open paren negative 7 closed squared equals 49, negative 7 is also the square root of 49. Does that make sense? Negative 7 is 49, and so is 7 and 7. So the square root of 49 is actually plus or minus 7. We're going to talk about it. Here we go. Key concepts. For any real number, a and b, if a squared equals b, then a is a square root of b. Right? Seems pretty straightforward. If 5 squared equals 25, then 5 is the square root of 25. Not too bad, right? Nope. We can also do this with fractions. This isn't in your book. But 1/2 times 1/2 is 1/4, so 1/2 squared is 1/4. Doesn't matter. It doesn't have to be a whole number. Just a piece of information. We're not going to do fractions today. It's coming, by the way, but it's not. All right. I'm out of the key concepts box and looking at this paragraph. Since I'm recording, I'm doing all the reading. So, to you guys over there. Okay. Since finding the square root of a number and squaring a number are inverse operations, it makes sense that the inverse of raising a number to the nth power is finding the nth root of that number. So x cubed is the same thing as the cube root of x. Those are inverses, I mean. Same thing. That's what all that's saying. X cubed inverse is the cube root of x. So here we go. The table below shows the relationship between raising a number to a power and taking its nth root, or taking its root number. Well, it just gives you a few examples. For example, a cubed equals 125. Well, what times itself 3 times is 125? Apparently it's 5. 5 times 5 is 25. 5 quarters makes $1.25. That's how I remember that one. So 5 is the cube root of 125. That makes sense?
Mm-hmm.
We're just building these roots off what you already know about square roots. All you need is 3 instead of 2. Okay, what about a to the 4th equals 81? What times itself times itself is 81. Well, that's 3. 3 times 3 is 9. Times 3 is 27. Times the final 3 is 81. So we just say 3 is the 4th root of 81. So all roots are just finding a number, multiplying it by itself however many times it asks for, and getting a number. Fifth root of 32, that's 2. That one I just have memorized. 5 2s makes 32. And last but not least, in fancy math symbols, a to the nth power equals b is the same thing as a times a times a times a times however many a's you need equals b. So you could have 57 a's there. And you'd say the 57th root of b is a. Yeah, I wouldn't want to sit there and figure that out, the 57th root of anything. I don't know about you. But I wouldn't. It would be a lot. It'd almost be impossible, really. So a is the nth root of b. So 5 to the 10th power would be some huge number, and you just say that number, its 10th root is 5. Pretty straightforward, or how are we doing?
Mm-hmm.
Okay. Well, here's the pattern suggests the following formal, mathy language, formal definition of an nth root. So there's a second key concepts box on this page, probably a new one in Braille. Here we go. In words, for any real number a and b, real numbers, and any positive integer n. Remember, positive integer n is important because it's a power. If a to the n equals b, then a is an nth root of b. So that's just it in fancy words. So and then they do the 32 example again. Since 2 to the 5th equals 32, 2 is the 5th root of 32. So I'm sure you see the pattern. It's whatever power it is the root 2. Just as something to remember. Time to turn the page and print. I'm sure there's a page break, Stormy. Is that right?
Yep.
Yep. All right. It's our favorite symbol, the symbol. We call it the radical. But, so Stormy, notice in Braille that it's G-H-N-A-R blank E-R, right?
Mm-hmm.
So the thing between the GH and the AR tells you the root. So this is just saying the nth root right here in Braille. So whatever number is between the GH and AR will tell you what root you're dealing with. And print, same deal. The thing that's in the V is the root. So since the n is in the V, then that tells you this is the nth root of 50. I don't know. Like, so when we used to deal in radicals, we just leave it blank. So if you don't see any root there, it's still the same old square root. A-R-E-R. That's plain old radical. The print, if there's nothing in the V, it's just square root. Alright. Now below the little picture, it says some numbers have more than one real nth root. We talked about that a little bit earlier. For example, 36 has 2 square roots, 6 and negative 6. Again, let's think about it. 6 squared is 36, but negative 6 squared is also 36. So we'd say, oh, the 2 roots are 6 and negative 6. When there is more than one real root, excuse me, the non-negative root is called the, well, principal root. Principal, like our principal. It's funny. for the principal root when no index is given, as in, well, we call that the square root of 36. I just told you this. Anyway, the radical sign indicates the principal square root. So again, if there's no n or anything in the b, then it's just the regular old thing. The symbol, the nth root of b, stands for the nth root of b. I don't know how else to say it when they show it, as a picture, because I'm used to reading it that way. So if you see something between the GH and the AR, it's telling you what root it is. If you see a number, it's telling you what root it is. So if n is an odd and b is a negative, there will be no non-negative roots. We'll test this out. Don't worry. In this case, the principal root is negative. Okay, let's look. The square root of 16, well, that one's pretty easy, right? What's the square root of 16?
4.
4! Okay, what if you have a negative sign out front? What's the negative of the square root of 16?
-4.
Negative 4, yeah. See how they have a plus or minus sound out front? Stormy? They should have a plus minus and then a AR16ER. They're saying, what's the positive and negative square root of 16?
Oh.
Yeah, there's no space between them or anything. Just says plus minus. So they want you to give plus or minus 4. Because you do what's inside the radical and keep your signs. Now here's where it gets kind of fun. What's the cube root of negative 125? What times itself 3 times will give you a negative 125? -5. So this is where that odd even thing comes in. If you have an odd power, or excuse me, in this case, if you have an odd root and you have a negative inside, your answer is going to be negative. Because the only way you can get a negative number and an odd power is to also be multiplying by a negative number. Yeah. So 3 negatives make a negative. Does that make sense, Stormy? Your number won't change. You could still say, well, the cube root of 125 is 5, but you just have to remember, since there's a negative in there and it's an odd root, your answer is going to be -5. Because there's no way we could get 5 times 5 times 5 to be negative 125. Same goes for here. What's the 4th root of 81? What's the negative of the 4th root of 81? Well, the 4th root of 81 is 3, but it has a negative sign out front, so you just say, oh, that's -3. This will take some practice. The more you folks encounter it, the more easy it'll come to your brain. But just remember what you learned about how if there's an even power and you have a negative, you're going to get a positive. If there's an odd power and a negative, you're going to get a negative. Practice. We will practice a lot of these. They're not complicated. It's just you'll have to become familiar with it. So they have a nice little table that explains this right below in the concept summary. So it says if your root, so the top row is n, that means the nth root, and the next column over is the nth root of b, where b is greater than 0. And then they give it to you again, it's the nth root of b where b is less than 0. So first column just gives you whether your root is even or odd. Your second column tells you what happens when it's a positive number under the radical. And the third column tells you whether what your answer will be when it's a negative under the radical. So this is just what would you say? Something to refer back to as you go through these. So let's look at the first row. So if we have an even root, we have one positive root and one negative root when it's when the number under the radical is positive. Because think about it. Again, a negative times a negative will always be a positive, and we will always have an even number of those, so it will always remain positive. So for instance, the fourth root of 625 is apparently plus or minus 5. Because again, negative 5 times negative 5 times negative 5 times negative 5 is also 625. So when you do this, recall that you must put a plus or minus sign out front when it's an even root. Because again, all the negatives multiplied together will be a positive. And all the positives, of course, will remain positive. But let's look to the right. And I don't know how they do it in Braille. There's no real answer. If you have the square root of negative 4, that doesn't make any sense. Can you think of two numbers that multiply together to be negative that are positive? No. There's no way that you could multiply negative 2 and negative 2 to get 4. And there's no way to multiply 2 and 2 to get negative 4. So if you ever see a negative under a plain old radical sign, you will never be able to find the answer. No real root. We'll talk about I later, Josiah. This could be done with I, but that's next. Does that make sense?
No.
No square root of negative 4. There's nothing multiplied by itself to equal negative 4. Never. 0. Nothing. Till next section. Alright. Let's look at the odd row. When your powers are odd, you'll have one positive root and no negative root. For instance, the cube root of 8 will never be negative. Ever. Because 3 negatives will always make a negative, right? So, the cube root of 8 will never be negative 2. Because negative 2 times negative 2 is 4, times negative 2 is actually negative 8. So, if you see an odd root and a positive number, it will always give you one positive root. Right now, I'm just trying to talk you through it. I know it will take some practice. Now, let's look at the last bit here. If there are no positive roots, when it's the other way around, if you have an odd power and a negative under the radical. So, there's no way you could have 5 negative numbers be a positive. In this case, because it says the fifth root of negative 32. So again, you will never have 5 negative numbers, or positive numbers, that will equal a negative. All 5 positive numbers will be a positive. So if you see a negative under the radical, and a 5 in your root, or any other odd number, 7, 9, 11, doesn't matter, your root will always be negative. We're going to practice. Find the example. Finally, we actually get to an example, huh? 5 plus or minus. Okay, they threw in an x. 25x to the 4th. Hey, look, it's a regular root, though. Are any of these negative under the radical? No. Have any weird roots? No.
No.
So we could treat this one just like a regular old problem.
So it's even.
Even, yeah, or even positive, I would say.
Even positive.
We call this the even positive square of your table, which is the top left in print, and in Braille it's the first one. So you just take out the square root of each thing. So what's the square root of 25?
5.
And what's the square root of x to the 4th? What times itself equals x to the 4th?
X squared.
Right. Their answer is just plus or minus 5x squared. Because remember, when you take the root of something, it comes out of the radical. And they did it a little differently in the book. And I don't mind which way you do it, because you can also separate it into a perfect square. They wrote plus or minus 20, the square root of 25x to the 4th is the same thing as 25, or plus or minus, open paren, 5x squared, close paren, squared. So you could separate it that way if you like. I'm personally fond of doing one thing at a time. It's totally up to you. If you want to separate it out into perfect squares, I'm totally cool with that. So. Alright, so that was an example of even positive. Okay, let's look at B. Where is it? There it is. It's on the right in print. Probably down in Braille. So ignore the negative out front. That comes later. Alright, it's all in parentheses, which is good. So this one, since it's also just a regular square root, right?
Mm-hmm.
What's the power of that big parenthesis? It should say negative, and then AR, open paren, y squared, plus 2, close to the 8th, close radical.
Mm-hmm.
Okay, so what's the power? It's in parentheses, right? So what's the power of this term? In this case, binomial. Anyone? Power? 8. This whole thing in parentheses is to the 8th.
Oh, yeah.
You can treat it like a like term. So that whole thing, what's the square root of that whole thing to the 8th? Anybody think this through? What if I said, let's just keep it simple. What if it said x to the 8th? What times itself is x to the 8th?
2.
No. What times what itself is x to the 8th?
No. X times 2.
Nope. It's a little harder to think about. Because, remember, to get x to the 8th, you have to add the powers together. So what times itself equals x to the 8th?
Oh.
Let's just keep it simple before we deal with this one.
I got 2 and 4. Oh.
For instance, x
4.
squared times x squared is x to the 4th. So what times what will give you x to the 8th? What times itself?
4.
Yeah, just say it. You're right. X to the
4th.
right. X to the 4th times x to the 4th is x to the 8th. Right. So if you saw something like square root of x to the 8th, that's the same thing as x to the 4th. Because all that means is x to the 4th squared is the same thing as x to the 8th. So it works the same way with this b here. So what do you think the square root of the quantity y squared plus 2 to the 8th is? Ignoring the negative out front right now. The same concept applies. It's in parentheses to the 8th. So what's the square root of something to the 8th?
2 and 4. So
Yeah.
2 and 4.
Oh, yeah, exactly. So because it's in parentheses, we're allowed to just treat that as one term. So your answer would be nothing more than negative, open, because that negative out front, open paren, y squared plus 2, close to the 4th. Same thing, because remember, they're like terms. You add their powers. So that whole thing to the 4th times that whole thing to the 4th is that thing to the 8th. Because they're like terms. So don't let that stump you. If you see a quantity in there, you can treat it as such. So again, in the book, they separate it out again. They have negative, open radical, open bracket, y squared plus 2, close, paren, to the 4th, close bracket, squared. Because when you multiply, that's a power of power rules. So it would work. So that one was just a trickery. It's still even positive, according to your table. You have an even root and positives inside. We don't know what y is, but it doesn't matter because it's inside a parentheses. Okay. Again, this will take practice. Let's look at C. Now it's odd positive, isn't it?
Mm-hmm.
Odd positive because we have an odd root. So if it's odd positive, that only means you have one positive root. So no need for plus or minus sign. So I like to go in order. This book likes to take it separate. So again, it's up to you. But for me, what's the 5th root of 32? 2.
2.
Yep, that one you'll have to memorize. What's the 5th root of x to the 15th? Yeah, x cubed. Because x cubed to the 5th is x to the 15th.
Oh, yeah.
What's the 5th root of y to the 20th? What time, it's power of power rules. So what's the 5th root of y to the 20th?
1 to the 5th? No.
Oh, it's y to the 4th.
Oh, yeah, 4.
And then you can always check yourself. You can say y to the 4th to the 5th, and you can say, oh, that's y to the 20th. So if you're never sure, you can always check. Because, again, the roots are the inverse of powers. So your answer is just 2x cubed y to the 4th. Because remember, once you take the 5th root of something, it exits the radical. All right. Uh-oh, D. Now, when you see this, you should automatically think something. What do you think, Stormy? No matter what.
So it's a negative
And what?
um
Right, it's negative, and what's the root?
it is
Since there's
odd.
nothing there.
Oh. Really odd.
If there's nothing there, that just means square root. So can we take the square root of a negative number yet?
Mm-mm.
No. So anytime at this point in your life, in your mathematical life, if you see a negative under a positive root, you can't do it. You just say not possible. Yet. You can even write yet. Because we haven't learned about I yet. So the square root of negative 9 does not exist. There is no negative or number multiplied together to get a negative at this point. Whew. Okay, we made it through example 1.
Wow.
Here's where it gets a little more tricky. I'm reading the paragraph right below the example, where it says, when you find the nth root of an even power and the result is an odd power, oh boy, that hurts my brain. If you find the nth root of an even power and the result is an odd power, you must take the absolute value of the result to ensure that the answer is non-negative. Oh, well, that makes sense.
Oh, yeah.
Yeah. Because if you have an odd power and an even root, remember, you can't have a negative number there. So, for instance, they give us an example, which is a good thing. Because negative 5 squared is 25, but so is 5. So what they're saying is, if you have a negative number in there, it can be the same thing as 5. So the square root of negative 5 squared is this absolute value of negative 5, which is the same thing as 5. Okay.
Mm-hmm.
And the same thing, a negative, if your result is odd, power. So for instance, the next one over says the square root of negative 2 to the 6th is the same thing as negative 2 cubed, which is the same thing as 8. So the absolute value signs are important because when you get the result of an odd power, for instance, the square root of x to the 6th would be x cubed, or in this case, the square root of negative 2 to the 6th is negative 2 cubed. You have to put it in absolute values because otherwise you will get a negative number, which we can't have under the square root. We can't. Your answer would be negative 2 cubed, which would be negative 8, which wouldn't make it work. Okay, we'll talk about this again, but just FYI. If your answer has an odd power and you came from even root, you have to put absolute values around it when there's a negative.
Mm-hmm.
All right. if the result is an even power, or you find the nth root of an odd power, there is no need to take the absolute value. Well, again, we talked about this. It's because if you have an even power, your negatives multiplied together will always be positive, won't they?
Mm-hmm.
So you don't need an absolute value, because they're positive. They might not always be positive when there's an odd power, and that's why they're making this distinction. Nth is an odd power. Then there's no need. All right. Last but not least, we're going to do example 2. It's on the top of the next page. Should be right below the page break.
Yep.
By using absolute values. Simplify. Part A. All right. Yeah, I like this one. I like this one. The 8th root of x to the 8th, everybody.
2.
Yeah, you got to use that absolute value because it's an even power, and you get an odd power as a result. So think about it. This is a trickery, and it's a fun thing to remember. What's the square root of x squared?
X.
X. So what do you think the 8th root of x to the 8th is?
8. Oh. No.
So if your power is the same thing as your root, you just get what's inside the radical.
Oh.
Oh. So the 8th root of x to the 8th is nothing more than x. However, we have to remember, since we got an odd power, because x to the first, that's an odd power,
Mm-hmm.
put absolute value signs around it, because it was an even root to begin with. So
Oh.
it's actually the absolute value of x, because we don't have any idea whether it's negative or not. Anytime, so the 4th root of n to the 4th, n. The 10th root of 1,572 to the 10th is 1,572. It always, always works. Okay? Alright. Let's look at B. Ooh, nasty. B is nasty. Because we have two separate things going on. First of all, it's open, 4th root, open radical. 81, open paren, a plus 1, close, to the 12th, end root.
No.
Yeah. So all that stuff is to the 4th root. This is why I encourage you to treat these separate. The quantity, n plus 1 to the 12th, is different than the 81. So again, you can treat them separately. So what's the 4th root of 81? Anybody have that memorized yet? We did do it earlier, yes. No problem. 3. The 4th root. So you could start there. You take a 3 out of the radical. You just pull it out because it's the 4th root of 81. Now, what is the 4th root of the quantity a plus 1 to the 12th? So you could think of it this way. What times 4 makes 12?
3.
3. So a plus 1 quantity to the 3rd is the 4th root of a to the 12th. Or that whole thing to the 12th. So it's the missing factor, if that helps. Because remember, when you're finding roots and powers, you multiply them together. So you have to say, what to the 4th makes to the 12th? So you just say, 4 times 3. Because you multiply the power. So because we had an even root, and we got an odd power out for the a plus 1, your answer is the 3 that we got the first with the 81, open absolute value, a plus 1 to the 3rd, close. Only when your answer is an odd power, you stick it in. If you have an even root and an odd power, it goes in absolute values. So that's why the 3 is fine, because that one's just a plain old number. 3 is easy. We already know that the 4th root of that is 3. Just, you know that. But we don't know what A is. We have no idea. So you have to put it all in parentheses in absolute values. So that thing cubed to the 4th power is A plus 1 to the 12th. You guys starting to see sort of how this is all fitting together?
Mm-hmm.
A little bit? Okay. All right. I'm not going to have you approximate radicals.
-3.
That -3 to the 4th would be 81.
So should the 3 also be inside the answer?
Well, you would think because you would get a positive number. I mean, excuse me, you would get the same number. Well, but they say 3 to the 1st. Yeah, because 3 to the 1st would be that odd power. Well, I don't have an answer for that.
Oh, okay.
Oh, that's fine. All right, homework. It's gonna start you on the top of the next page, actually. Hold on. I. What happened? Ah! Okay. Oh, I see. Okay. How nice should I be? I don't know.
Really nice.
Oh,
I agree.
I don't agree. This is something you really need to practice. This whole chapter is stuff you need to practice. 7 through 14 for now. Start there. And then I would like you to do 16 on, as many as you can. But 7 through 14 is required. Hold on, let me go stop the recording. 7 through 14 is required. Skip 15 and do, I don't know, 16 to 18. As many as you can possibly fit into your life. You will need them. I promise it will pay off later. I don't usually believe in plug and chug, but in factoring in this stuff, I do believe in it. Okay. I want to stop recording.